Hi, this is Ujjwal Saxena, and we are here to learn about LTSPICE. So our software requirements is LTSPICE, and this software is made by Linear Technologies. SPICE means simulation program with integrated circuit emphasis. I have LTSPICE 4, and it is available on net, free of cost. It's just 17 MB software, so you can easily download it. So first of all, let's open this. Choose a new schematic. You can also select this from the files option, new schematic. And there are various icons available over here, and we'll understand about them in the due course of this video. So let's make something and understand what all these icons do. So first of all, go to this component icon, click this, and go to NPN transistor. Let's plot transfer characteristics for a NPN transistor. Now it remains selected till you escape from this. So I have escaped, and what else I need is a voltage source. So go to the voltage source, select OK, put this here and escape, and select a current source. Okay, current source. Now you see that this current source is having a direction opposite to the direction we want for our circuit. So go to this option, it says move. So you can select this component from this move command, and you can see that there are two icons which provide the flipping option. This will give the mirror image, but we don't want a mirror image. We have to rotate it by 180 degree. So I'm clicking twice and I flipped this twice. Okay, I put this here. Now we have to make the connections. So choose this wire, click on this, connect it. Click on this, click, connect it. Click on this and connect the emitter, connected. Click on this again and connected. Now what else do we need is a ground. Never forget to mention or to put a ground. This is used as a reference. If you won't use this, it will be considered as floating nodes. It won't have any reference to measure the voltage. Okay, and now the second step is to assign values to these voltage and current sources. So for that, I'll click on this DC value. Let's say I take 5 volts DC. If I won't mention volts, it will still be taken as 5 volts. Volt is the default unit. Now click on this. Let's say I take 10 milliampere. Okay, so the base current is 10 milliamperes. Now just in case you want to select NPN transistor, you don't want this default NPN transistor, so you can go to pick new transistor and choose any of the transistor of your choice. There are various manufacturers available: Philips, ZX, Fairchild, etc., etc., and they have their SPICE models mentioned over here. So according to your requirement, whatever your circuit needs, you can choose the SPICE model according to that. The SPICE model defines various characteristics of the transistor, like its VTO, its channel width, its channel length, and many other things related to that. So I'm canceling this I was just showing you about what this thing does. Now what else do I need? Okay, now I have to simulate this. So you can just simulate this from this run icon directly from here, or you can go to simulate and run. Okay, so go to run. I have to do the DC sweep because I'm using DC sources over here. So first source is my V1. Okay, so I've selected V1. You can see the graph, or you can plot the graph in linear, octave, or decade, whatever you want. Start value 0. Let's take the stop value to be 4, 5, whatever you want. And the increment 0 0.1, 0 0.2, 0 0.3, okay, whatever. And since I'm using two sources, so the second source is my I1. Select I1. Linear is fine. Start value is 0. Stop value is 10 milliamperes. Okay. And what should I increment this? 0.5 milliampere. If I won't mention ampere over here, so it will take the default value, milliampere over here, so it will take the default value to be amperes. Okay, now you see, okay, for this let's save this first. Save as. I'm using a Ujjwal Saxena underscore Saxena 1. Save this. Yes, wherever you can know. Let's save it in on the desktop. So first of all, go to the desktop. Okay, and save it here. Okay, now you can drag this and make the screen bigger. This window pane will give you the output. Okay, so again go run. Now you can see that a probe appears. This probe measures the voltage of various nodes or various wires. I want to measure the voltage of this wire, so I'll just go and click on this. It will plot the voltage. If I want to plot the current, so I'll be using this icon. As soon as you'll go on any source, it will show you the current option. The current icon will appear. Okay, this is a multimeter, and as soon as I'll click on this, here you can see, double click this and the previous graph will disappear. You can see that this is the graph that you have learned in your textbooks. This is the saturation region over here. This is the IDSS, which has saturated, the cutoff region, the active region, and break off region somewhere over here. It won't show you the break off region. Now do one thing, select NPN, go to pick new transistor and select another transistor and say OK and run this again. Now you can see that the graph has changed a bit. This is just because the internal characteristics of the transistor has changed. So according to your choice, you can make selections of the transistor or any other component that you are using for your circuit design. Apart from this, we have different um, other icons like this undo command, from which you can as usual, like you can don't want to you just want to undo some previous step, so you can go to previous step. A drag command, if you just want to drag something from one position to another, so you can just choose this drag. Okay. The frequently used components like diode, inductor, capacitor, resistor, etc. are given over here directly. Print, in case you have completed a circuit design and you want to print it, so you can print it directly from here. Cut, it's a good option which gives you the ability to just remove a wire or a component uh, from anywhere, and you can undo this. So apart from this, there are, you can close these tabs directly from here. Nothing to mention in this. Zoom out and zoom in options. You can zoom in this and zoom it out. uh, Apart from this, there are the same options given in this. View, simulate, you can edit the simulation command from here, like I used this uh, before. So you can change the various parameters that you defined, like this. If you want to increment this with 0.2 milliamperes, so you can edit this and run this again. Okay. uh, this was all in the introductory video. This is Ujjwal Saxena. Thank you.